let's solve for some angles. All of these problems will involve either isosceles triangles, parallelograms, or simply parallel lines cut by transversal. It's always important to read the problem because it will tell you information that you need to put into the diagram to help you solve it. So let's do that. In the diagram of parallelogram, FRED. So automatically we know it's a parallelogram. I'm going to mark the sides with arrows to show that those are parallel. And if it's a parallelogram, I know a couple things. I know that opposite angles are congruent. So angle R and this angle over here are congruent. And angle E and this angle over here are congruent. Those are some of the properties of a parallelogram. If you don't know those properties, I'll link a video in the description that will kind of go over that real quickly with you. Let's continue reading. ED is extended to A. AF is drawn such that AF is congruent to DF. That's very important. AF is congruent to DF. Now, those two sides are congruent, which means that this is an isosceles triangle. And we know something about isosceles triangles. We know that the base angles are congruent. So how do you identify the base angle? Well, one of the things that I like to do is to highlight the congruent sides. So this side and that side are the congruent sides, which means this is the, and I do this in air quotes, top of the triangle, because there's no such thing as a top of a triangle. But let's say that the correct word is vertex. So that's the top of the triangle, which means that the other side down here is the base. All right, that's not always true because, I mean, it's not always true that the side that looks like the bottom is the base. Here's an example. Here's a triangle. If I told you these two sides are congruent, then if I highlight those sides, right now this is like the top of the triangle, meaning that this is the base. So it's always important that you pay attention to what side is the base and what sides are congruent. Okay, so now we identified this side to be the base, AD. The base angles, which are the angles that touch the base, are the congruent angles. I'm going to put a triple marker here because I already put a double for those. All right, so anything with a triple angle marker are congruent. If the measure of angle R is 124 degrees, so this is 124, which means that this is 124 because opposite angles are congruent in the parallelogram. What is the measure of angle AFD? AFD is this one up here. So if that's 124, now we know that two angles that form a straight angle must add up to 180. So what is 180 minus 124? Pull up my calculator. 180 minus 124 is, 180 minus 124 is 56. So this angle over here is 56 degrees, which means this one is also 56 degrees because we already know that the base angles are congruent. Now, the three angles in the triangle always sum to 180 degrees. So how much is this missing angle? Let's call it x. We could say that 56 plus 56 plus that missing angle x is equal to 180. Now, you don't have to do it with this equation. You could have simply added the 56 and 56, which is 56 plus 56 is 112. Now subtract that from 180 and you'll get 68 degrees. All right, so you could do it completely without this, but I find like sometimes the equation helps students, make sense of the thing. The three angles must add up to 180. This is one angle, that's another angle, that's the other angle. The three angles must add up to 180. If you solve this, you will get 68 degrees. And that's it. Check out the next one. In parallelogram, okay, or automatically parallelogram, QRST. So that's the entire outer shape. Let's put those little parallel symbols. Diagonal TR is drawn. U and V are points on TS and QR respectively. Great. and UV intersects TRW. Excellent. If angle S is 60 degrees, that's 60, I'm automatically just going to mark that as 60 because we know opposite angles in a parallelogram are congruent. Measure of angle SRT is 83. So if you don't know how to to find an angle, this is what you do. So you read it in the order given over here. So S to R to T, and what angle did we really capture? What corner did we really get there? Well, we got this corner. All right, so that's the angle that they're talking about. So this angle is 83 degrees. And the measure of angle TWU, so TWU, right? That's this corner over here. So TWU is 35 degrees. Let's put that in. It's a little tiny diagram here. What is the measure of angle WVQ? So W, V, and V to Q. This is the corner that we're trapping. So that's the angle that they're looking for. Now, I've seen about 4 or 5 different ways that you could solve this problem. It's a very open and nice problem in that regard. But what it'll tell you is that if you just find as many angles as you can, you'll ultimately somehow end up at the right place. So let's actually do that. I guess I'll use green. So let's see. One of the things I see is this triangle. Let me highlight it. All right, now when you look at this, everybody's going to see something slightly different, and that's quite okay. But if you look at that triangle, TRS, now for that triangle, I erased that by accident, the angles must add up to 180. So I'm going to subtract this 83, subtract this 60, and we'll end up with whatever that remains to be, because those 3 angles must add up to 180. All right, so let's do that. So on my calculator, I'm typing 180 minus 83, and then I'm going to minus 60 from that, and I remain with 37. So I know this angle over here is 37 degrees. Now, these 2 lines are parallel, and you could look at this as the transversal, right? I'm kind of extending it so you could see it like how you usually see it in your class. All right, look at just the purple, ignore everything else. Parallel lines cut by transversal. Now, alternate interior angles, I'm gonna use this terminology. Please don't ever write this anywhere. But the armpits of the Z, do you see the Z? The armpits of the Z, the armpit is just the corner. The armpits of the Z are alternate interior angles and are congruent because the lines are parallel. So if that angle over there is 37, then this angle here must also be 37. Okay, so we're getting somewhere. Okay, I see a pathway out already. Now, if this angle is 35, this is 35 because opposite angles, vertical angles are congruent, right? Like when you have an X, any 2 lines intersecting, this angle is congruent to that one, this one is congruent to that one. And that's precisely what we have here. We have that X, so this is congruent to this, and this one is congruent to that one. Now we don't need to know all of them. All I need to know is that one was 35. And from here, I could calculate this angle because the 3 angles in that triangle must add up to 180. So I'm going to take 180 and I'm going to subtract 35 and also subtract 37. All right, now let's see what we get. So I'm subtracting away those 2 angles from the 180 because the sum of the angles in the triangle is 180, and we get 108. So this angle over here is 108 degrees. So if that's 108, how much is this angle on the other side? Well, 180 minus 108 is 72. So we end up with 72 degrees as our final answer. 72 degrees. Now, you may have noticed, I'm not going to mention anything more than this, but if you added this up and that up, you'll get 72. If you don't understand why this is 72 because of that, don't bother about it right now. It's not necessary. But I will try to leave a link in the description to explain exterior angles of a triangle. Okay, let's move on. Here's another problem. In the diagram below, parallelogram. Okay, is it okay if I don't mark the parallel sides? I'm gonna do it. I don't feel comfortable not marking it. So that's a parallelogram. That's 70. I know this is 70 right away. I'm gonna keep reading the problem though. Angle C is 70, great. And the measure of angle ROS is 65. They marked it for us already. What is the measurement of angle KSO? That's how you read this, by the way. Measurement of angle KSO. So this angle over here is what they want to find. Well, guess what? I hope that you could see that we have a triangle over here with two angles in it. Once you know two angles, it is easy to find the third one because they always add up to 180 in any triangle. So I'm going to find that this angle over here by doing 180 minus 70, then I'm going to minus that other angle of 65, and it will remain with that third angle. So 180 minus 70 minus 65, and we end up at 45 degrees. And now we're basically almost done because these two angles, they form a straight angle, right? Which means that they add up to 180 degrees themselves. So what's 180 minus the 45? Well, that's 135. And there we go. So the measure of angle KSO is 135 degrees. All right, here we have another one. This one's a little bit special because it introduces something that we didn't really talk about as yet. In the diagram below of parallelogram, here we go again. Parallelogram, ABCD. ABCD is this bigger outer quadrilateral. So that's a parallelogram. AFGB. Okay, that's this bottom line, AFGB. Okay, CF bisects angle DCB. Hold on. Let's just focus on this one sentence here for a second, this one phrase. CF is this line, bisects angle DCB. So DCB is this angle. So it bisects that entire angle. Bisect means to cut in half. So that means that this piece of the angle is congruent to this piece of the angle. So in my diagram, the way I'm going to mark that is simply by putting a little single angle mark there. And I'm marking them a little bit offset because I don't want to do one big thing like that. It looks like I'm just talking about angle DCB. But to show that I'm talking about two separate angles, make it a little bit offset. All right, so single angle mark means that they're congruent. DG is this line, bisects angle ADC, so it's bisecting this angle over here. So I'm going to put a double and a double, and again I'm going to make them a little bit offset to show that I'm talking about two separate angles. And CF and DG intersect at E. If the measure of angle B is 75, okay, so this is 75, then the measure of angle EFA is, so EF, E to F to A is this angle over here. So they want to know that angle. Okay, I'll put a question mark instead. This is the angle that they want to know. Okay. So let's do something. Now, immediately my mind jumps to opposite angles in a parallelogram are congruent. So that's 75. I know that this entire angle here is 75, but it gets split in half, right? It gets bisected by DG. So what is 75 divided by 2? 75 divided by 2 is 37.5. So I know this piece over here is 37.5. So is this 37.5. Now let's see. My goal is to get to this thing here. All right. If this is 75, I know that this angle, the entire thing, is 105. Why? Consecutive angles in a parallelogram add up to 180. All right. When I say consecutive, if you didn't look at that other video I posted, if this is a parallelogram, just a quick picture over here, consecutive means one right after the other. So if I'm talking about this angle, if that's my angle, a consecutive angle to that angle would be the one over here or the one over here, right? So either one is a consecutive angle. They always add up to 180. That's definitely a property that you should know. So this angle also gets cut in half. It also gets bisected. So let's see, what is 105 divided by 2? And that is 52.5. So 52.5 for each. Let's write that in blue because now it's getting a little bit hard to see here. 37.5. 37.5. And what I said this was 52.5. 52.5. Okay. I'm going to erase the parallel symbols now because just to keep it cleaner. Are we getting closer to where we want to get to? Maybe. I'm looking now at, and I don't want you to think that this is the only way to solve this. There are probably multiple ways. I'm looking at this triangle over here. And I'm going to solve for this angle. Why? I'm not sure. I'm just trying to find as many angles as I can until I get to the angle that I really, really want. Okay, so the three angles in that triangle must sum to 180. So I'm going to do 180 minus 37.5. And then I'm going to subtract that 52.5 as well. And I end up at 90 degrees. Ooh. All right. So this is a nice 90-degree angle. I'm going to put a little box. And since these two angles are vertical, remember what I told you with the x, if you have two lines crossing, the angles are opposite each other are called vertical angles, and they're congruent. So this angle is also congruent to that one. Okay. So that's 90, which means that this is also 90 over here. They're all 90, right? So I'm just going to put one of them to be 90. Okay. So just for the sake of it, I'm going to write the 90 just so that we could see it. Right. Just so that we have a number. Okay, 90. Huh, okay. Now, remember the armpit of the Z thing I was telling you about, which are alternate interior angles? Please, please, please don't ever say armpit to the Z to anybody. That's just between you and me. I'm looking at this Z. Do you guys see that Z? So if this is 52.5, this is also 52.5. Let's mark that in. So this is 52.5. Okay, I guess I didn't even need to do those 90-degree angles because we're almost done now. These two angles form a straight angle. All right, so 52.5 subtracted from 180, and we have our final answer. 180 minus 52.5, and we get 127.5. So our final answer is 127.5 degrees. Okay. This next one, I am going to leave you to do this one. I will post the answer in the comments, and I'll pin it. Or maybe the description so you could check it to see if you're right. But I'm not going to do this one with you. Use this as a challenge. Just know that it's a parallelogram. Bisect means to cut in half. All right, so the bisectors of angle ABC and DCB meet at E. So that just means that this is cutting that angle in half. And this line is cutting that angle in half. Just to kind of hint you in the right way. And what's a measure of angle BEC? B to E to C this is the angle that we're trapping like that. So that's the angle that they're talking about. You have to figure out what that angle is. All right. Good luck, and I'll catch you in the next one.